Okay, so let's look here at the very first question that we run across here. In a right triangle, angle A and angle B are acute angles. Which of the following is a true statement? All right, so, well, let's draw a picture here, right? We've got a right triangle, so I'll go ahead and call it, put the right angle in there, okay? And we have that angle A and angle B are the acute angles. So that means that's got to be angle A or B. Or we could swap them too, but those are the acute angles there. So it's A or B or C. Yes, Derek?
I can't find this page.
You can't find this paper? All right.
So I'll give you another copy here. We'll see if I have enough. I have two, so. No, it's not, I have this one. Oh, I thought it was long ways. Oh, no. It's, yeah, it's right there. Yeah, I got it. You have it, Jason?
Yeah, I don't know.
Well,
Me neither.
it's what we were working on yesterday, the stapled page that we had yesterday. Yeah, it's there. It's on the back maybe or something like that. Again, the stapling's like weird on it. I apologize. It's the very first one, number one. You don't have it. Look what you got right there.
Right there?
Yeah, give me that. Yeah, no, it looks everything zoomed in on it.
Yeah, I'm sorry. They're going to zoom in. I'm sorry, yes.
So
Everyone else has it, yes? We're okay?
That was supposed to be B, Mr. Woody.
1 second. Okay. What was your comment there, Ramel?
I said that was supposed to always be B. We're C.
Oh, it doesn't have to be, no. Okay, and in this case, because we're told angle A and angle B are acute angles, B cannot be the right angle because B has to be acute, so it's got to be these two that are the A and the B. Okay? So, in this case, folks, what did we just finish talking about from the warm-up, right? Okay? Does cosine of A have to equal tangent of B? If we look up here, right, is that true in this case? Is cosine of A equal to the tangent of B?
Yes. No.
No, they're not the same. Not identical. Is the tangent of B equal to the cosine of A? That's just the same thing flipped. That's weird. Okay, so it can't be B either. All right, let's look at C. Sine of A. Does that have to equal cosine of B?
Yeah.
Yeah. And let's look at D, just to make sure. Sine of B, does that have to equal the tangent of A?
Wait.
No. So remember what we talked about there. Sine of A is always going to be the same thing as the cosine of the other angle, B. Okay, so in this case, it's just C. Okay, it's just C. If you guys aren't sure about that, if you want to kind of check yourself to see whether it's right or not, just draw a little picture there and just put in some side lengths. Now, an easy kind of right triangle is like the 3, 4, 5 right triangle. That's always going to be true. And just write your ratios out and see which one of these are true. Okay.
How do you tell that?
So you can just, I can just write out, what is cosine of A? Well, cosine, here's angle A, cosine is 3 over 5. Right? And then tangent of B, tangent is opposite over adjacent, so it's 3 over 4. So those two numbers are not the same. Okay? And so on and so forth for the rest of them. You'll see for sine of A and cosine of B, it's the same thing. And that's true in general. The sine of one acute angle in a right triangle is equal to the cosine of the other acute angle. And also what Haley pointed out with the tangents. The tangent of one acute angle is the reciprocal of the tangent of the other angle. That's all. All right, number 2. That one was pretty quick. All right, number 2. Frederick Middle School and Frederick High School are only 32 feet apart. The height of the taller school is 45 feet. The angle of depression from the top of the taller school to the top of the shorter school is 10 degrees. What is the height of the shorter building? What should we maybe do here to help us out with this problem? Yeah, draw a picture, okay? So I'm going to draw a taller building. Here, I'm going to draw a shorter building. Okay? The taller building is Frederick High School. Oh, I'm sorry, I'm off the screen. Let me scoot it out a little bit. There we go. Thank you. Okay. Oh, it doesn't say which one's taller, which one's shorter. Oh, well, we'll say FHS is the taller one, and FMS is the shorter one. Okay? Okay, very good. Ramel and Matt, you guys want it in the office. ASAP. So that's right now. There you go. Office. Okay? The height of the taller school is 45 feet. Okay, so that taller school is 45 feet tall. There you go, sir. Okay. And they're 32 feet apart. Okay. The angle of depression from the top of the taller school to the top of the shorter school is 10 degrees. So that means, if we look at the top of that taller school, this is like the horizontal, and then an angle of depression means we're going to be angling up or angled down. We're going to angle down to the top of the shorter school, and that angle of depression is 10 degrees.
Why do you make that other straight line that
I drew that in because that's like the horizontal. You always measure from the horizontal. If it's an angle of elevation, you measure up from the horizontal. If it's an angle of depression, you measure down from the horizontal. Okay?
So the line is under if it's not, if it's going up.
Correct. If it's an angle of depression, you're measuring down from the horizontal.
No, I'm saying if you have an angle like, you know, like the depression's going down,
Mhm.
but if you have an angle that's going up, that horizontal line will be under it.
Correct. Oh, yes. Correct. Yes. Sorry. Yes. Which means, by the way, right, since this is the angle of depression, if someone's looking from the top of Frederick High School to the bottom of Frederick Middle School, what's the angle of elevation if someone's on the top of Frederick Middle School up to the high school? What's this angle measure got to be right here? So if it's 10 degrees as well. This is also going to be 10 degrees right there.
Why did you make a straight line?
Because again, it's if you're looking at the if you're on Frederick Middle School from the angle from the horizontal, it measures up to the top of the Frederick High School there.
Shouldn't the line be drawn up then?
I'm sorry?
Shouldn't the line connect to the Frederick High School building? If you're looking up, like why would you look back?
Just for someone that's observing from Frederick Middle School, they would have to look up, and that measurement from the horizontal, they have to look 10 degrees from the horizontal up. Someone who's looking from the horizontal, it's 10 degrees up from a flat line kind of basically thing. If you have to look 10 degrees down from Frederick High School, from Frederick Middle School, you have to look 10 degrees up to match it.
The line isn't showing that.
No, but the idea is that there is, if it's from, the 10 degrees is from the horizontal, from a straight line out. It's 10 degrees up.
Can I just make my line like right next to the depression line because that doesn't make sense? Because I get what you're saying, but that line doesn't make sense.
Okay, so don't draw it in then if it doesn't make sense to you. All right, so we want to find the height of Frederick Middle School. So what should we call that? We're going to have to call that x, right? We don't know it. That's what we're trying to find. Okay. And so if you look here, what type of shape do I have right here? A triangle. And specifically, what kind of triangle? A right triangle. Okay. What is the length of this side of that right triangle? 32, right? Because it's the distance between the two buildings. Okay, I'll kind of zoom in more on this one. We'll kind of come back to that in a second, okay? 32 feet is the distance between the two buildings. This height of this triangle, is the height of this triangle 45 feet? Yeah, it's not. 45 is the full distance here, okay? This distance is like, you take the 45 and then we get rid of the part that's the height of Frederick Middle School. So what could I label this as? 45, and if I take away the x, I'm left with what this has to be, right? This little distance right here is x, because that's like the same height as the middle school right there. So that means, what does this height got to be? 45 minus x, exactly right, is that height. I know this is like really crammed in there, but that's the idea there, is 45 minus x is the height. Okay? And now in this right triangle here, I have an angle, and I have the opposite leg of that right triangle, and I have the adjacent leg of that right triangle. So, what trig ratio can we use? I have an opposite leg and an adjacent leg. So what trig ratio has opposite leg and adjacent leg in it? Tangent. And so we're going to say tangent, I'm going to run out of space, I'll put it down here. Tangent of 10 degrees is equal to, thank you. Okay. Pythagorean theorem would not work here because we don't know what this side is. And besides, we're not trying to find the hypotenuse here, we're trying to find x. And so we want to set this up using these two pieces and then the angle there. So we're going to say tangent of 10 is opposite 45 minus x over adjacent 32. So there's our setup. Okay?
So how do you know what angle to look from to get those? Because you can look from any...
Well, so, right, I could have chosen this angle right here if I'd wanted to, EK, but you're right. And that would be 80 degrees, I guess, because it's, 80 plus 10 plus 90 gives you 180. So you could use the 80. And if you use the 80 degree angle right here, you would use opposite 32 over 45 minus x. So it would, flip the order, that's all. So it just depends on whichever angle you selected to use there. So, okay? All right, so at this point, now that we have it set up, what do we got to do to solve? Multiply both sides by 32. You got it, Josh. Exactly right. That's our starting point. The 32's cancel. I'm left with 45 minus x. And I'm going to go ahead and type this in my calculator. 32 times tangent of 10 is about 5.6, we'll say. Okay? And then to continue getting the x by itself, what's with the x that we need to get rid of? 45. So I'm going to subtract 45 from both sides. Okay? 5.6 minus 45, negative 39.4. You might say to me, Mr. Wimar, that doesn't make sense. We have a negative answer. But what's left over here on the right-hand side? Negative x. And so to get the x by itself, to make that not negative anymore, what should I do to both sides? Yeah, we can divide both sides by -1 or multiply both sides by -1. What are you going to do there? The negatives now cancel, and I'm left with positive 39.4. Okay? So that's the height of the middle school. And if we go back to our multiple choice, okay, it said to round our answer to the nearest whole foot. So what's the nearest whole foot? 39. There it is. Okay? There it is. All right. Questions on any of that? That's our setup there. Okay, that one's a little bit funky because it had, the 45 minus x in there, but it's the same thing. Once you get it set up, just get the x by itself. Okay, use your algebra. All right, let's move on then. Number 3. An airplane takes off at Frederick Municipal Airport. The pilot began, pilot began a 7-degree ascent. So you guys know what an ascent is, right? You're what? Going up, right? Descent, going down. Ascent, going up, okay? So it began a 7-degree ascent at a height of 952 feet above sea level, okay? So that means they are taking off at a 7-degree angle, and they're already 952 feet above sea level. The cruising altitude is 2,794 feet. At the start of its ascent, which of the following diagrams could be used to find the distance the airplane will travel at its cruising altitude? Okay, so Matt says A. Okay, so let's take a look here, right? So if we look, for example, at C, the 7 degrees is not in the right spot. The plane's taking off at a 7-degree angle, so it can't be C. D, the plane is taking off at a 7-degree angle. That's right, but then it's saying this length right here is 1,842, and the x is the height. But we're not trying to find the altitude. We're not trying to find how high the plane's going to be. We already know what it's going to be, so it can't be that.
Shouldn't that number not even exist because it doesn't exist in the problem?
So if you look here, though, we're left with A and B. Both of these take off at 7 degrees. Both give you the length the plane is flying, kind of that distance there that's flying, the x. Okay, one has 2,794. One has 1,842. Okay. The answer here is actually B. Okay, so here's why. Here's why. The plane is already starting 952 feet above sea level. So you have to take it off of the cruising altitude, 2,794. The plane is actually only going to climb 1,842 feet total vertically. Okay? If it were starting out at sea level, then yes, A would be the answer. Okay, but since it's not starting at sea level, it's starting above sea level that much. You have to subtract it from that total height there to get the 1,842. And then that's why B is the answer there. So you see where that comes from there, Ekeva?
Yeah.
Okay, so that's why. The plane's already starting out 952 feet above sea level, so to climb to 2,794, 2794 minus 952 leaves us with the 1,842. That's what it actually has to climb vertically to get to the cruising altitude. Okay, so that's why B is the answer there. Questions on any of that? All right, let's scoot on then to number 9. Number 9. Okay. So again, number 9 is a trig. 10 was a similarity one. Yes, these are the two special right triangles here. Okay, and this is a, which one of the special right triangles are we looking at here? 30, 60, 90. Exactly right. Okay, so again, will you have these two triangles given to you for the CRES? No, so you need to remember them. Okay, the 30, 60, 90, let's label it here. What's this side going to be labeled as? X. Yep, what's the hypotenuse labeled as? 2x, and that leaves this as x times the square root of 3. Okay, so if we look here, we're supposed to select the set of side lengths that could not correspond to the triangle below. So let's look at what we have here for letter A. Okay, A tells us 10, 5 square roots of 3, and 5. Does this one, could this one be the side lengths for this triangle?
Well, how do you know what side roots are?
Good question. Okay, x, you'll notice, is right here, right? That's the smallest side, right? Because this side is twice x, and then this side is x times the square root of 3, which will still make x make x bigger. So this side's always the smallest side, and then you use that to then figure out the rest of the sides.
So, and your square root of 3, that's always your middle one?
That's always your middle one, exactly right. So if you look at A here, for example, the 5 is the smallest side, so that means it has to correspond to this side.
Well, that actually doesn't work because the square root of 3 is always your middle one. I mean, that's not right. Look at D.
We'll get to that. We'll get to that. Let's just see if A works. So if I plug 5 in for x here, because it's the lowest, shortest one, so it's going to be this side, okay? What's this side going to be? 2 times 5, which is what? 10, and that's that side length. And then what will this side be? 5 times the square root of 3. So that one works, okay? So we don't want to pick that one because that one works. All right, let's look at B, okay? B has x is 2, okay? And that means its longest length has got to be what? Ooh. It says 6, but what should it be? If x is 2, this should be 4. So there's the one that doesn't work. Okay? So let's look at D. Okay, you're right. This one's a little bit funky. The shortest of these three sides is the 3 root 3. I'll write that one in here in this case. Okay?
How do you know that?
You can use your calculator. I'll show you. 3 square root of 3 is that. 6 square root of 3 is that. So you can see that's... Oh, I'm sorry. 3 square root of 3 is 5 point something, which is the shorter. So you can use your calculator to help you with that, Ikeva. Okay. And then, so are you okay then with seeing that it doesn't work as well?
Well, I mean, the side root of x is 5.2, right?
So, right, about 5.2, and then this would be twice that, which is about that.
Which is like
10.3.
So that could work.
So it does match. And then if you do 3 square root of 3 times the square root of 3, it does give you the 9. So yeah, it does work actually there. So that one does work, and so does the C when you check that one. So B is the only one that does not work. It does not match the ratios. That 6 should be a 4, okay? The shortest side should always be half of the longest side. All right, so that's number 9. Any questions on that one? We're all good there? All right, so the last one we're going to look at then is number 14, a free response question. And then we'll be done. I'll give you guys your homework assignment here, okay? Question? No? All right, so if you look here, we have a right triangle, right? So it's a dead giveaway. What kind of things can we use here? SOHCAHTOA. Can we use Pythagorean Theorem here? Yeah, potentially we could, okay? So in fact it says, so let's read the directions here. It says, you are building a ramp for a loading dock. The length of the ramp is 3 feet longer than the height of the ramp. So you see they even label that for us. The length of the ramp right here is 3 feet longer than the height. The height is x, so the ramp is x plus 3. That's 3 times longer. If it's just 3 feet longer, you're adding 3 feet to it. So the length of along the ground is 9 feet. So there's our shape. Note it's not drawn to scale, so keep that in mind. All right, it says to find the length and the height of the ramp. Use mathematics to explain your answer. Well, let's see here. We don't have any of the acute angles here. So can we use sine, cosine, or tangent to help solve here?
Yeah.
We could, but we don't have any angles. All right, so what else could we use to set up, to like relate all three of these sides?
Well, why is there 0?
So, well, hold on a second, let me answer one question at a time. So, Zaria, we can't use those because we don't know if it's a 30, 60, 90 or a 45, 45. Again, we don't know what these two angles are. It looks like it might be a 30, 60, 90, but we don't know. Good thinking, but we're not sure if it's a 30, 60, 90. So we can't use the special right triangles. Okay, what was your question?
Why is there 0?
That's supposed to be, that's an angle. It's a Greek letter, it's supposed to be a Greek letter theta. It looks like it's actually like this. It's just to represent an angle. It's a variable.
Well, why isn't there one on the other side?
Because I think later on we're going to be finding this specific angle and not this one. So that's why it's labeled there for us already. All right. So we can't use the special rights. We can't use trigonometry because we don't have the angles. What's the only other way that we can relate all three sides of a right triangle? Pythagorean Theorem. Okay, so if that's the case, we're going to do c squared equals a squared plus b squared, or the other way around. If you want to write a squared plus b squared equals c squared, that's fine. Okay, what is my c in this problem? Yeah, the quantity x plus 3. That's going to get squared. What's my a in this problem? Okay, and then what's the b? It could be the x. And what's the b got to be then, Jaden? X. Yeah, so it's x squared. Okay, now we have to simplify this. All right. So 9 squared is 81. I'm going to do this side first because it's easier. And then x squared is just x squared. X plus 3 quantity squared. Do you guys remember how to do that?
Isn't it 2x?
So when you square x squared, when you square x plus 3 squared, that is x plus 3 times itself. So what do we have to do when we see something like this? What do we do? Remember you...
Distribute.
Yeah, distribute. We got to FOIL or distribute there. That's right. Okay? So we'll multiply the x's together. So it's the first, right? X squared plus the outer, 3x, plus the inner, 3x, and then plus 3 times 3 is 9. All right? And so that simplifies to what? X squared plus 6x plus 9. Yep. I'm sorry if I'm going too fast there.
Why don't you do it, like, when you have x plus 3 squared, and you write x plus 3 2 times, how come you don't do anything to the 3? Because technically that should be, what, 9?
We do, eventually. When you square something, right, EK, you multiply it by itself. So that's what I'm showing here. I'm just multiplying it by itself.
Yeah, I know that, but shouldn't it be x plus 9 plus, and then x plus 9?
Well, no, because we haven't actually done the squaring yet. When you square something, right, so for example, if I write 3 squared, that's the same thing as saying 3 times 3. And then you do the multiplication and you get 9. Right? So here, I'm saying x plus 3 squared is x plus 3 times x plus 3, multiplying it by itself. And then when we actually do the multiplication, yeah, a 9 does show up there. That's the idea. Okay? So that means this left-hand side over here is equal to x squared plus 6x plus 9. Okay? And then what can we do to start solving here? Yeah, if we look here, we have x squareds on both sides. So to get them together, what should I do? Well, they're on different sides, so we don't want to just add them up. I got to subtract one of the x squareds away. That's right. And what happens to the x squareds? They cancel. So we're left with 6x plus 9 equals 81. And then I got to solve this equation. I'm running out of space here, so I'll go this direction. So now what should I do to both sides to keep solving for x? Yeah, subtract 9. So I get 6x equals 72. And then what? Yep, divide by 6. X is... it's 12. X is 12. Okay? So there's x is 12. So that means up here, this side is a length of 12 feet. Okay? And then what's this side length going to be? The hypotenuse?
15.
15. That's right. Very good. Okay? So then, yeah, so the next one we're supposed to do, letter B, find the angle of elevation, theta. So find this angle. If you don't like using that word, you can just change it to like an x or a y or something like that. In fact, let's just use a y because we already used the variable x.
Mister, do you have like another pen?
Try that one. I know it's not as pretty as the purple one, but, okay. Now, if I want to find the angle theta, well, now that I have some side measures here, we can use trigonometry. Okay, so do I want to use sine, cosine, or tangent here of the angle y? Sure, sine works. Does anyone think we could use cosine? Cosine will work too, okay? Because we have the adjacent side and we have the hypotenuse. We actually could use, any of the trig ratios here because we have all three sides. But since you said sine, let's use sine. So sine of our angle y here, sine of y is going to equal what over what?
12 over 15.
Yep, 12 over 15, you got it. Okay. And then at this point, to get the y by itself, we have to use our calculators. Remember, what buttons we press on our calculators to get just the y there? Or to what do we have to do here? Remember what we have to do to get this? Let's zoom out some here. We should press the second button and then sine. We have to do sine inverse. And we type in the 12 over 15. Because we have to get the sine, we have to get rid of the sine. To cancel out sine, you do sine inverse, which is second sine in your calculator. Okay. Sine inverse of 12 over 15 like that. And you get about 53.1, round to the nearest tenth of a degree, so 53.1 degrees. Yep. Go for it. Okay. Questions on any of that so far? Any questions?
Is that feet or inches?
It's degrees. When you're talking about an angle, it's degrees. Okay. And the letter C. After a while, you realize this ramp is too long. You want to design a shorter ramp with the same angle of elevation. Sketch and label the dimensions of your new ramp below. So basically, if we want to keep all the angle measures here, but we don't want it to be the same length, what can we do to these three sides here? To make them shorter, what can we do? We want to keep the same kind of triangle. We want to basically come up with a similar triangle here.
How do you know to draw the triangle? Like, why can't you draw a square?
Well, because it says you want to design a shorter ramp with the same angle of elevation. Sketch and label the dimensions of your new ramp. So we want to draw a ramp. So we're going to just draw like a similar kind of version of this ramp that we have up here, down here. Okay. So we want it to be similar here, folks. So what could we do? I have 9, 12, and 15. I want to make it smaller, but I need to like basically use like a scale by a scale factor. So what's an easy way to kind of like make all these smaller? What are these all divisible by? Yeah, let's just divide them all by 3. So that would mean this side is 3, this side is 4, and this side is 5. Boom. Yeah, we're dilating basically. Making it smaller by a factor of 3. Do we have to divide by 3 here? No. If Cable wants to divide all 3 of those sides by 2, making it like 4.5, 6, and 7.5 feet, that's fine too. You don't have to divide, but we have to divide by 3, but we need to make it smaller.
So you could technically do -2.
Not -2. We want to divide because remember it's like a scale factor kind of thing. We want to like shrink it by the same amount.
Well, -2 would still be shrinking.
It would be shrinking it. You're right, but it wouldn't be shrinking it proportionately. Proportionately, we want to shrink it, so we have to like divide by a number.
How
So
would it not be proportionally because you're minusing the same number?
well, so let's see that hypothetically here. So let's say you wanted to subtract 2 from all of these, right? So let me just do that real quick, just so I can show you. Okay. So subtract 2 from that. That's 13. Sorry. Subtract 2 from that. That's 10. Subtract 2 from that. It's 7. All right. So if you look here, so what would our proportions be? 7 over 9 would be one of them, right? Because 7 of them and 9 match up. 10 over 12.
Why are you doing ratio?
Because they have to maintain the same proportions. That means the ratios need to be the same. And then 13 over 15. Okay.
Is that image over pre-image?
Or
is that just...
Yeah, that's image, right? Because this is the shrunken version of it. I subtracted 2, so image over pre-image.
Like, could you 15 over 13, or
You could, because we're just doing the proportions here, so you could. Yeah, but if you look at it this way, Cable, watch this. 7 divided by 9 is 0.77777. 10 divided by 12, it's not the same proportion.
Do they all have to be the same?
Yeah, so you would need to multiply or divide by the same number, not subtract. Subtracting, you lose the shape of the triangle then. This keeps the same shape of the triangle, just makes it smaller, it shrinks it.
So you could, like, technically do 5 over 15 instead of 15 over 5. Like, it's not, like, image over image.
Oh, in this case, right, because I'm just trying to show the proportion. In general, though, it's a good idea to just always do image over pre-image, though. Just if you want to keep it, like, the same.
And the one we drew would be image.
This would be like the image, yep, because we shrunk it from the original. Okay, and finally, letter D, use the criteria for triangle similarity, angle, angle, side, 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 or side, angle, side. Justify why the triangle formed by your two ramps are similar. So, why must our two ramps be similar? Well, if you look here, what do I have? I have 3 sides and 3 sides. So what's one way we could justify that these two triangles are similar? So the other ratios, we could say side, side, side. And so what we can do here is actually look at the ratios of the sides. So now if I do 3 over 9,
Why are you doing
50.
I'm sorry, it's out of the thing there. Because 3 corresponds to the side of the 9, right? And I could show then, okay, 4 over 12, and I could show 5 over 15. Now, are all these ratios the same? Well, 3 over 9, 1/3. 4 over 12, 0.3333. 5 over 15, 0.33333. And so they're all equal. Okay, so that's why they're similar.
So what would angle, angle, or side, angle, side look like?
Well, actually here, did we have to use side, side, side?
No.
What else could we have used? We also could have used angle, angle, because if this angle is 53.10, that angle is also 53.10, and they both have a right angle. So they're also both similar by angle, angle as well.
Like, how would you show it? Like,
You could just show that, you could just say something like this. We could say angle, angle, because two angles are congruent or equal. Or I should say two pairs of angles.
and what would it look like if it was side, angle, side?
Well, actually, we could also do side, angle, side here, too. If you look, Ikeba, because we have a side, angle, and then a side. We have 2 sides, and then the angle between them. And then we have another 2 sides, and we have this angle between them, also 53.1 degrees there. So what could we say? You would need to show the ratios. So you do like 5 over 15. Ooh, I'm kind of like equals 5 over 15 equals 3 over 9. And the angle between is congruent or equal, whatever you want to say there. Okay? So you could actually use all 3 there. It just depends on your justification. I think probably side, side, side is the easiest one. Maybe angle, angle, though, too.
So the angle between is congruent.
Mm-hmm.
Congruent to what?
Each other. They're both 53.1 degrees. So they're congruent to themselves. Okay?
Can you move it down some?
Yep. Okay.